All right, so we did our lesson on the distributive property, and we chose my lesson. We kind of illustrated the before and after slide, how we changed the lesson, how we wanted it to appear. So the first one, the before, you can see it just, the problem's written out, and then there's a pair of shorts and a t-shirt to kind of represent what the problem is talking about. The after slide that we decided to, we put in a few things. We added in 6 people, which is kind of neat, just a little app, a nice visual. And we also added in a sentence that was a let statement for T representing the cost of the t-shirts and S representing the cost of the amount of shorts, so that they could figure out the 2 different expressions for the cost of the purchases. Our next slide, we have our before, which we're given the distributive property from the slide before for the problem. And now we have the distributive property at the bottom, which the students were meant to create their own definition for the distributive property. But we changed it in our after slide to, instead of giving them the distributive property, what they should have found, we're asking them what they actually discovered. So here the students can come up and write down their ideas and then compare and contrast what that is. And then we have the distributive property. It's actually hidden. So if you want to just drag down the hidden bar, and we actually have a definition given to them. So we say, okay, you found it out. Now here is what the definition actually is.
So before, we had the 6 multiplied by t plus s in the brackets, and we were just comparing how it was similar after you distribute the 6 to both the t and the s. We had it in green and red. We decided to change it so that the algebra tiles were the same color as what we're trying to find, which is the t-shirt. So we let the yellow block represent the t-shirt, and the blue block represent the shorts. And so again, we're just going to show how if you distribute it, you get the same number of algebra tiles for each one. And then for this one, before we had expressions that included such things as A or B, and we just changed it by changing it to be variables instead for every question. So instead using the variables X, Y, and Z.
Okay, so our next one, yeah. So the before is just it has the distributive property and it gives the area, but then now in our after, we decide that maybe we should use or let the students label the sides on what they would be, and we gave them what the insides would be, so then they found it on themselves what side A and B and C would be. And then we just gave some essential questions like how do we find the area of a rectangle? And they're able to use that essential question to form their own ideas, and then try and find 2 different expressions to represent the area of the whole rectangle. So then they're able to just create their own instead of us just feeding it to them. And then the next one is the perimeter activity. We didn't change this one too much. We made the font bigger, but we gave another essential question on how we find the perimeter of the rectangle. So then they're able to go back and retrieve from their own memory on how to find the perimeter, instead of us just, again, giving them the formula for it. And then we just use the same question from the before to the after. And then our last slide that Tiffany used was just the homework page. We didn't change the homework. We just made it bigger for the students to see, and that's all we changed. Thank you.